Senior Lecturer Production Engineering, Government Polytechnic College, Amritsar. Today in this session of Production and Industrial Engineering, we are going to discuss some topics from the subject of Industrial Metrology and Quality Control, which is a most important subject for the production and industrial engineering students. The various topics we are going to discuss are height gauges, depth gauges and filler gauges. I hope you understand and enjoy this session. So, let us start with the first topic. First of all, if we discuss about the rationale of this subject, that is why this subject is important from the students of production and industrial engineering. The diploma holders studying this course are responsible for measure and inspection for ensuring quality of the product on the shop floor. For this purpose, knowledge and skill about standards of measurements, limits, fits and tolerances, types of inspection and various measuring instruments like height, depth, filler gauges, etc. and SQC, which is statistical quality control, is necessary. He or she must be aware of quality system, hence this subject. So, the first topic is the height gauges. If we discuss the definition of height gauges, a height gauge is a measuring device used either for determining the height of something or for repetition marking of items to be worked on. The former type of height gauges is often used in doctors' surgeries to find the height of people. These measuring tools are used in metalworking or metrology to either set or measure vertical distances. The pointer is sharpened to allow it to act as a scriber and assist in marking out work pieces. They may also be used to measure the height of an object by using the underside of the scriber as the datum. The datum may be permanently fixed or the height gauge may have provision to adjust the scale. This is done by sliding the scale vertically along the body of the height gauge by turning a fine deep screw at the top of the gauge. Then with the scriber set to the same level as the base, the scale can be matched to it. This adjustment allows different scribers or probes to be used, as well as adjusting for any error in a damaged or reshaped probes. Types of height gauges. So, if we discuss the type of height gauges, there are two types of height gauges. First is vernier height gauge and second is electronic height gauge. So, first vernier height gauge. The vernier height gauge has the additional refinement of a vernier scale for greater accuracy in reading or setting the tools. So, here the diagram can show is the diagram of vernier height gauge. The various main parts of this vernier height gauge are: this is the main measuring jaw, this is the base of this height gauge, locking screw, slider, this is vernier scale, fine adjustment screw, main scale of this vernier, auxiliary head and beam. So, if we discuss the main parts of this vernier height gauge, the first is the base of this vernier height gauge. Vernier height gauge consists of a fine ground and lapped base to ensure rigidity and stability. The base is made robust in construction. So, in this case, this is the base of this vernier height gauge. Second main part of this vernier height gauge is the beam. Beam is a vertical graduated column which is supported on the base. The guiding edge and faces of the beam are perfectly flat. The surface of the beam should have dull finished for the ease of reading. The second part of main part of this height gauge is the slider. Slider has a good sliding fit along the full length of the beam. It consists of a vernier head carrying the vernier scale and a clamping screw. Next is the measuring jaw and the scriber. A measuring jaw and the scriber is attached to the front of vernier head. This is the measuring jaw. The upper and lower surfaces of the measuring jaw should be perfectly flat and parallel to the base of the height gauge. The projection of scriber beyond the jaw should be 25 mm minimum. The vernier must be at 0 position while taking the readings. The next main part of this vernier height gauge is auxiliary heads. It is attached to the beam above the vernier head. It consists of a suitable fittings to give a fine adjustment of the slider and clamping screw. It also provided so that the slider could be clamped to the beam effectively after the fine adjustments. So, if we discuss the various uses of this vernier height gauge, it is used with the surface plate to measure the vertical heights. The difference in height can also be measured by taking vernier scale reading at each height and subtracting these values. So, the various precautions to be taken while using this vernier height gauge are: all the measurements should be performed on the surface plate. The beam of the height gauge should be clear and free from the dust. Springing of measuring jaw should always be avoided. Final setting of vernier height gauge should made after the sliding has been locked to the column, and the height gauge should be tested for straightness, squareness and parallelism of beam, measuring jaw and scriber surfaces. Second type of vernier height gauge is the electronic height gauge. The electronic height gauge has a digital readout that gives the height. So, this is the diagram of electronic height gauge. Here we can see this is the main measuring jaw and this is the locking screw used, and these are the screen provided for readings. These buttons are provided. This is for preset, this is for hold, this is for on off and this is for 0 set. So, this is the main shape of this vernier electronic height gauge. Next is the vernier scale. A vernier scale is an additional scale which allows a distance or angle measurement to be read more precisely than directly reading a uniformly divided straight or circular measurement scale. It is a sliding secondary scale that is used to indicate where the measurement lies when it is in between two of the marks on the main scale. Vernier are common on the sextants used in navigation, scientific instruments used to conduct experiments, mechanics, measuring tools, all sort, but especially caliper and micrometers used to work materials to fine tolerances and used in surveying. When a measurement is taken by mechanical means using one of the above mentioned instruments, the measure is read off a finely marked data scale, which is the fixed scale in the diagram. The measures are taken will usually between two of the smallest graduations on this scale. The indicating scale vernier in diagram we use to provide an even finer additional level of precision without resorting to estimation. So, this is the main diagram of a vernier caliper. Here we can see the fixed jaw which is connected to this main scale of this vernier, and this is the movable jaw which is connected to this vernier scale. So, if we discuss this vernier caliper, to understand the least count of this vernier caliper, we must first get the idea of the structure of a vernier caliper. Vernier caliper is an instrument used to measure the internal and external diameter of small tubes, depth of given vessels, diameter of thick wires, etc. It has two scales on the vernier scale and other is the main scale. The vernier scale is also called the sliding scale and it slides on the main scale which is fixed. There are two portions on a vernier caliper on which objects to be measured are kept. One is the portion labeled A. Here is the A portion. In the diagram, it allows for measurement of internal diameters. So, this A portion of this vernier caliper is used to measure the internal diameter of the object, and the other is the portion labeled as B. This is the B portion of this vernier, which is for the measurement of the external diameter. So, external diameter of any object can be measured by using this B side of vernier. And a third part of vernier caliper which is used for keeping the objects to be measured is labeled as C in the diagram. This is the C portion of this vernier caliper. It allows for finding the depth of basalt. So, this C part of this vernier caliper is used to measure the depth of vessels. The part labeled B in the diagram is used for measuring external diameters. Here the object whose diameter is to be measured is kept in between a fixed jaw of the vernier caliper and the movable jaw which is continuous with the vernier scale. Least count of a vernier caliper. The least count of vernier caliper is, as the name suggests, the least or the finest measurement you can take with the help of that vernier caliper. It is measured by dividing the least count of the main scale by the total number of divisions on the vernier scale. So, least count of the main scale is calibrated in millimeters. To get the least count of the main scale, count the number of divisions on the main scale in 1 centimeter of it. Divide 1 centimeter into that much number of divisions. The value obtained is the least count of the main scale in centimeter. For example, if there are 10 divisions in 1 centimeter of the main scale, its least count is 1 divided by 10 is equal to 0.01 centimeters. Second is number of divisions on vernier scale. In most vernier calipers, the vernier scale has 10 divisions. Count the number of divisions on the vernier scale. Use a magnifying glass if necessary to take the better readings. Least count of a vernier caliper. Thus, least count of vernier caliper is equal to least count of the main scale divided by number of divisions on the vernier scale. For most vernier calipers, least count of main scale is equal to 0.01 centimeters. Number of divisions on vernier scale is equal to 10 divisions. Thus, least count of vernier caliper is equal to 0.01 divided by 10 centimeter is equal to 0.001 centimeters. Thus, since the least count of vernier caliper is 0.001 centimeter, it can be said that when measuring with the help this vernier caliper, you can get an accuracy of 0.001 centimeters. Thus, since vernier caliper can efficiently measure dimensions up to 10 raised to power minus 3 centimeters, they are extensively used to measure the internal and external diameters of tubes as well as the dimensions of many more objects as needed in the industry. So, here we can see the vernier scale. So, this is the fixed edge of this vernier and this is the main scale of this vernier. This is the sliding edge and this is the vernier scale of this vernier caliper. So, here if we discuss the procedure for taking the observations, first of all study the main scale and vernier scale of this vernier caliper which is to be used. Calculate the value of one small division of main scale, then count the number of divisions on vernier scale. Dividing the value of one division of main scale by number of divisions on vernier scale. So, this is here the main scale and this is the vernier scale, and thus the least count is calculated. Before using the instrument, check the zero error. The zero line on the vernier scale must coincide with the zero on the main scale. These are the zeros of both scales. Now, adjust the workpiece between jaws. The excessive pressure should not apply on workpiece while fitting between two jaws. Now, take the reading on main scale in mm and observing the division just on left side of the zero of vernier scale. Then number of divisions of vernier scale which exactly coincide with any line of the main scale is counted. The reading is calculated by the formula. So, total reading is equal to the main scale reading plus number of coinciding dividing of vernier scale multiplied by the least count of this vernier scale. So, this is the procedure for taking the reading on this vernier scale. So, if we discuss, there are some sources of error while using this vernier scale. The various sources of error which may exist while taking measurements the help of vernier caliper or under. The error may be due to the incorrect location of workpiece between the measuring jaws. These are the two measuring jaws. The caliper jaws should be perfectly perpendicular to the workpiece. Second is the accuracy of measurement depends upon condition of jaws. The jaws should be free from wear and other surface defects. There should not be any play between sliding jaws and main scales. There should be sliding fit and shears free movement of vernier scale on main scale. The accuracy depends upon the straightness of the beam and the squareness of the sliding jaws with respect to the beam. Any derivations in these parameters may lead to inaccurate results while reading this vernier scale. So, there may be some precautions while using these vernier calipers. The zero error must be checked before starting the measurement, and if it is in the instrument, it must be considered. While measuring outside diameter, ensure that measuring surface of jaws must be perpendicular to the workpiece. These jaws are used for measuring the outside diameter of the object. While the movable jaws, excessive pressure should not be applied. To avoid this, move the jaw with light touch. The sliding jaw must be clamped before taking the reading to ensure its squareness. The vernier caliper should not be used as a substitute of wrench or hammers. The measuring surface of jaws should be free from dust, dirt and oils. So, again this is the diagram of the main scale and the vernier scale. An enlarged view of above caliper shows it has a resolution or precision of 0.02 mm. The reading is 3.58 mm. The 3 mm is read off from the upper fixed data scale, and the 0.5 mm is obtained from the lower sliding indicating scale at the point of closest alignment between the two scales. So, if we see the reading here just before the 0 of this vernier scale, here is the reading is 3 on main scale, and if we see the which reading is just aligned with this main scale is the 5/8 position of this reading. So, total reading here comes out is 3.58 mm. The least count in this case was 0.02 mm. So, here we have some example how a vernier scale works. So, there is an object whose diameter is to be measured with this vernier scale. In this case, this is the object shown whose diameter is to be measured. This is the 5 of this fixed scale, and this is the sliding vernier scale. 5 just coincide with the 0 of this sliding scale. So, here in this case reading comes out to be 5 5.0 mm. Here in this case 5 is just before the 0 of this vernier scale. So, first reading, main reading is comes out to be 5, and the first reading on this main scale just coincide with this vernier scale. So, the total reading comes out to be 5.1 mm. Here in this case, here is 5 just before the 0 of this vernier scale. So, main reading will comes out 5, and here the fifth reading is just coincide with this reading of fixed scale. So, here the total reading comes out to be 5.5 mm. The vernier scale is constructed so that it is spaced at constant fraction of the fixed main scale. So, for a decimal measuring device, each mark on the vernier would be spaced 9/10 of those on the main scale. If you put the two scales together with 0 points aligned, then the first mark on the vernier scale will be 1/10 short of the first main scale mark, the second 2/10 short, and so on up to the ninth mark, which would be misaligned by 9/10 only when a full 10 mark have been counted would there be an alignment, because the 10th mark would be 10/10, that is a whole main scale unit short, and will therefore align with the ninth mark on the main scale. So, now if you move the vernier by a small amount, say 1/10 of its fixed main scale, the only pair of marks which comes into alignment with the first pair, since these were the only one originally misaligned by 1/10, if we had moved to 2/10, then the second pair and only the second would be in alignment, since these are the only ones which were originally misaligned by the amount. So, if we had moved it 5/10, then the fifth pair and only the fifth would be in alignment, and so on for any movement. Only one pair of marks will be in alignment, and this pair will show what is the value of the small displacement. Vernier accuracy. Vernier accuracy is the ability of a human eye to see clearly. Vernier scale can be read because the human eye can detect whether two line segments are aligned, or if they are slightly off alignment. Vernier accuracy is the ability by a person to detect the proper alignment of two line segments. So, in the most people, vernier accuracy is particularly high, allowing one to accurately differentiate between aligned and misaligned mark of a vernier scale. Precautions taken while using vernier height gauge. So, first is all the measurement should be performed on a surface plate. So, ਜਦੋਂ ਵੀ vernier height gauge use करना है, तो all the reading should be performed on a surface plate to have better results. The base of height gauge should be clear and free from dust. Springing of measuring jar should always be avoided.